Hi everyone, my name is Sus Nanikhan. First of all, how are you? If you're doing great, then it's good. And if you're doing bad, I hope this video makes you feel a little bit better because what I'm going to be talking to you about are some pretty cool things. So today, I will attempt to answer this broad question on why do Saturn and possibly other gas giants have extremely hot atmospheres? And the reason why I chose this question was because I was genuinely curious on why do these gas giants have extremely hot atmospheres, even though they're much farther away from the sun compared to other planets. For example, Jupiter. Its its planet is much hotter compared to Mars, which is weird because Mars is much closer to the sun, so it would be more hot. But we're going to discuss today on why. So let's get started. So, the main reason why this happened is because the auroras from the sun causes the high temperatures to occur in Saturn and contributes to the extremely hot atmosphere. And two, the fusion of the composition of these gas giants emit heat, which contributes to the extremely hot atmospheres. And let's talk about what a gas giant is. A gas giant is simply a planet made out of gas. And we can see this in our solar system with Jupiter, Saturn, Uranus, and Neptune. Let's talk about the main compositions of these gas giants. Jupiter and Saturn. Mainly dominant gases include ammonia, hydrogen, helium, and methane. And for example, when hydrogen and helium fuse together, they emit heat like stars. That creates energy and contributes to the high temperatures in their planet's atmospheres. So I am going to try to explain the auroras as simple as possible. And I'm going to use Earth as an example because it has a similar function, and we all know this planet, and learning about Earth more can help us discover new things that scientists have been discovering in the solar system's planet. Okay, so let's start. Here is a diagram of the process of auroras. So, auroras are formed when the sun sends heat and light through the planet's magnetic field lines through the north and south poles. So, north and south poles are here. And yes, so when the energy travels down the magnetic field lines through the north and south pole of the Earth's atmosphere, the sun's energy particles interact with our atmosphere and thus displays the most beautiful, majestic lights I've ever seen. Here it is. So, yes, Aurora Borealis, or Australis, also nicknamed Northern and Southern Lights, one of nature's greatest creations, in my opinion. So you see in our planet, the oxygen gives off green and red light, while nitrogen glows blue and purple. And I will show you Jupiter's aurora. It's also pretty nice. It's like a little swirl of blue on the top. Looks like it popped out of a Disney creation. Okay, so you might ask, how does this relate to the extremely hot atmospheres in these gas giants? Well, we're going to talk about magnetospheres now. So when the energy from the sun goes through the planet's magnetosphere, if you don't know what a magnetosphere is, magnetosphere just deflects most of the particles in the sun, but also traps and causes the high temperatures in the atmospheres. And it contributes to the cause of auroras. Like I said, it's similar to planet Earth, but you can also think of this as greenhouse gases. One thing magnetospheres and greenhouse gases have in common is greenhouse gases, they're gaseous compounds that trap heat from the sun, right? And it causes the global temperature in our planet to go up, which contributes to global warming. You can think of it similarly to what an aurora does in these gas giants. Except they're not the same, since magnetospheres deflects the the particles from the sun. Well, it also traps it as well. So it's quite analogous, but yes, they're just a bit different. Okay, let's talk about what happens in these gas giants as well. So auroras are accompanied with Joule heating, which means that they're accompanied with electric currents in these gas giants that generate heat. And I'll show you, oh, I already showed you Jupiter's auroras. So yes, that's my, I guess that's mostly the end of my presentation, but I would love to talk to you about why I said possibly other gas giants have extremely hot atmospheres. This is because there's just very little evidence of what's happening in Neptune and Uranus, but we can infer that since Jupiter and Saturn has these same events that are occurring and it contributes to their extremely hot atmospheres, it could be analogous to Uranus and Neptune's function. So yes, it's a theory. We just have very little evidence, but right now scientists are trying to figure out more about what's happening in these gas giants. And yes, I'm hoping to see what scientists have found out so far in the future. So yes, thank you for watching this video, and I hope you've learned something today. And yes, have a great rest of the day. Bye.